Hello everyone, myself Professor Chavan. Today we are going to start the fourth chapter from our 11th Science CBSE board for the subject physics. Okay, so the fourth chapter is based on the motion in a two dimension. In the third chapter we have learned about the motion in a one dimension. Okay, in that also we have take one glance about what is the motion in a two dimension, what is the motion in three dimension. Okay, so in a motion in a one dimension we have seen that whenever a body is following a motion in a straight line, then in that case the only one coordinate of the position of a body changes. Okay, and that's why that type of motion is known as the motion in a one dimension. Also we have learned about the motion in a two dimension. What is the motion in a two dimension? When the body is changing its position, then at that time what is happening? The two coordinates of the body changes. Okay, we have the three coordinates in our Cartesian system. Out of that three coordinates, the two coordinates of the body changes there. Okay, the position of a body changes, then there is a change in the two coordinates of the position. Then in that case the motion of a body is called as the motion in a two dimension. Okay, as we know, the motion in a one dimension is the motion along a straight line, or we can say that motion is along the axis. Okay, along the one straight axis. Okay, if it starts along the x-axis, then it will go only along the x-axis. If it will start along the y-axis, then it will go along the y-axis. If it starts along the z-axis, then it will only go along the z-axis. Okay, but what is happening in a two-dimensional? Okay, so that we have to see in our fourth chapter. Okay, so the fourth chapter is chapter 4, motion in two dimension. Okay, so if we take the example of a motion in a two dimension, then in that case what is important that the position of a body changes, then there is the change in the two coordinates of a body. Okay, so what is the example of a two dimension? We have seen when we throw any ball in a higher position to cover some distance. Okay, suppose you are standing at the one corner of your classroom and you have to throw a ball to the another corner of your friend. Okay, then what will happen there? When you throw a ball, you are giving some particular height to that ball, and with that height you throw that ball. Okay, with that height you throw this ball, and when you throw this ball, then what is happening there? As you throw this ball, it will get some height. Okay, it will get some height, and after reaching some height, again it will come down. Okay, again it will come down. So what is happening there? Its height is changing, and as well as it is also covering some horizontal distance. Okay, means its y coordinates is also changing and its x-axis coordinates is also changing. Okay, so what is happening initially for when you throw a ball towards your friend, then what is happening there? That when you throw a ball, it will catch some height. Okay, it will get some height. Then what is happening there? The height is increasing, the horizontal distance is also going on. The height is increasing, the horizontal distance also going on. Okay, and at some particular height, what is happening there? That the horizontal height is not increasing further. Okay, this vertical height is not increasing, but what is happening there? That from that particular height, this ball will fall down, but either its height is decreasing, it is also covering some horizontal distance. Okay, it will cover some horizontal distance. It is not the case that when it stops going in a higher and it also stopping its horizontal motion, it is not happening there. So what is happening there? That along with its vertical distance, there is a change in its horizontal distance. Also, when it stops its motion in a vertical direction, then what is happening there? It also goes in a forward direction, that is in a horizontal direction. It is not stopping there. So it comes down to some particular height up to your friend. Okay, it reaches up to your friend. So during that direction, what is happening there, that it is changing its position in the two directions, that is in a vertical direction also and in the horizontal direction also. Okay, it's changing its direction in the both the direction, that is in a vertical and in a horizontal. Okay, so if we draw its graph, then you will get one curve like this. Okay, suppose this is the y and this is the x, then your friend is at this position, okay, and you are at this corner. Okay, so what is happening, you are throwing the ball, and when you throw a ball, the ball will reach at this position, and from some position it will start dropping its height. Okay, so during this, if you see, okay, what is happening there, that with respect to time, with respect to this horizontal direction, its vertical height is increasing. Okay, with respect to horizontal distance, its vertical height is increasing, and up to some particular point, up to this point, what is happening, it is the highest point that the ball can reach. Okay, it is the height point that the ball can reach, and from this point it will start its motion in a downward direction. Okay, it starts its motion in a downward direction, and but it keeps on going in this horizontal direction. Okay, it keeps on going in this horizontal direction, and that's why there is change in position of a ball in a two direction. First one, here it's changing its position along the x direction also, it changing its position along the y direction also. Okay, so in this case, if you think that which positions are changing, which coordinates are changing, only two coordinates are changing. Okay, if you think about the position of a ball in terms of the Cartesian system, then you come to know that it's only two coordinates are changing. Its x coordinate is changing and its y coordinate is also changing. Okay, so what is happening here, that there is change in position in a ball, then there is a change in position or change in the only two coordinates. Its z coordinates remains the same. Okay, its z coordinates remains as it is, but its x and y coordinates are changing there. So such a type of motion, when the body is performing, then that type of motion is known as the two-dimensional motion. Okay, if we write down, then when there is change in position of an object, then if there is change in only two coordinates, okay, if there is change in only two coordinates, then such a type of motion is known as two-dimensional motion. Okay, two-dimensional motion. So when there is change in position of object and there is a change in only two coordinates, then such a type of motion is known as a two-dimension. Okay, then if you think about this motion, you can come to know that how is the graph of the motion, how the body is changing its position and how it is performing its length of path. Okay, so it is going by this curve. Okay, it is going by this curve, and in a two-dimensional, this type of curve is known as the projectile curve. Okay, this type of curve is known as the projectile curve. Okay, projectile. We have to study this curve in detail. Just I am giving you the introduction that this type of curve is known as the projectile curve. Okay, we have to go for its equations also, how the projectile motion of a body is given, which are the equations, how much is the time period, that all things we have to study in our further lectures. Okay, so in a two-dimensional, the motion, such type of motion is known as the projectile motion also. Okay, so if we take the another example, that when we tie one stone to the one end of the thread, okay, and if we give some motion to that thread, then what is happening, that stone is revolving only around its circular path. Okay, it will keep its motion in only along the circular path. Then what is happening there, if you consider the motion of that stone, okay, then suppose this is the your one end of the thread and this is the another end of the thread, and here is the stone. Okay, here is the stone. Then what is happening there, when you give the motion to this thread, then what is happening, the stone will perform the circular motion. Okay, that stone is performing the circular motion. Then if you see here, then you come to know that the stone is changing its coordinates only 2. Okay, there is change in position of the stone, and with respect to that there is change in position of the only 2 coordinates of the stone. Okay, only 2 coordinates of the stones are changing. Suppose if we draw one Cartesian here, okay, if we draw one Cartesian here, then you will come to know that when the stone is at this position, then it is having this coordinate. Okay, this is x coordinate, this is y coordinate. Okay, when the stone is changing its position at this level, then what is happening, at this level, this is the x coordinate, this is the y coordinate. Then at this level, this is the x coordinate, this is the y coordinate. Okay, so this is y1, this is y2, x1, x2. So along that circular motion, there is only change in 2 coordinates of the stone. Okay, when the stone is changing its position, then what is happening there, that there is only change in the 2 coordinates of that stone. Okay, it's only x coordinate changing, y coordinate changing. Here the x coordinate changing, the y coordinate changing. Here x coordinate changing, y coordinate changing. Okay, so only there is a change in only 2 coordinates. Okay, so if we think about the motion of a stone tying to the thread, then that stone is performing the circular motion, but during that circular motion it is changing its only 2 coordinates, and that's why that type of motion is also known as the 2-dimension. Okay, that type of motion is also known as the 2-dimension. Now suppose if we think about the plane of motion of this stone. Okay, if we think about this plane of motion of the stone, then you come to know that the stone is performing its motion only in a xy plane. Okay, it is performing its motion only in xy plane. It is not going in a yz plane, it is not going in a xz plane. Okay, suppose here if you think this is the xy and here is the z. Okay, then here is the z. Then if you think about the motion of this stone, then you come to know that there is only change along the x and y coordinate. So the stone is performing the motion in only a single plane. Okay, then we can say that the 2-dimensional motion is the motion in a single plane. Okay, we can say that whenever there is a 2-dimensional motion, there is the motion in a single plane, and in the plane in which there is the motion of that particular object, that plane is known as the plane of motion. Okay, that plane is known as the plane of motion. Okay, so here in this case, which is the plane of motion? Here this xy plane is the plane of motion. Okay, this xy plane is the plane of motion. Now in this case, if we tie a stone and rotate it along this horizontal direction, okay, this horizontal direction, then in that case, suppose the stone is performing its rotation in this direction. Okay, at that time the stone will rotate in this direction. Then in which plane the stone is performing its motion? then you can say that the stone is performing its motion in the xz plane. Okay, you can say here that plane is the xz plane. Okay, so that's why we can say that the two-dimensional motion is the motion in the plane. Okay, and the plane in which the motion takes place, that plane is known as the plane of motion. Okay, that plane is known as the plane of motion, and in this case, if it is performing the rotational motion, then we can say it as the plane of rotation also. Okay, if there is the circular motion, then we can say it as the plane of rotation, and if it is going only by this any curve, then we have to say there the plane of motion. Okay, so these are the different concepts: the plane of motion, the plane of rotation. Okay, so these things we have to study in our this fourth chapter, that is the motion in a two dimension. Okay, so in the motion in a two dimension, we have to go for the study of the ultimate speed performed by the body, okay, and its relation with the change in position with the change in the direction of its coordinates. Okay, we have to study the change in the coordinates, in which direction there is a change in the direction, okay, in which direction there is a change in the position, that part we have to study, and how the speed of that body changes with respect to that position. Okay, then if we think about some concept in this two-dimensional, then if we take the example of the one, okay, so in this case, if we are standing here, okay, if you are standing here and you have to reach up to this point B, okay, you are standing here at point A and you have to reach up to this point A with the speed of 2 meters per second, okay, with the speed of 2 meters per second, and this total distance is 10 meters. Okay, this total distance is 10 meters. Then if I told you you have to travel by the 10 meter and reach up to point B, okay, in within a 5 seconds with the velocity of 2 meters per second, then even if you go by the 10 meter, then you are not reaching the point B, because I am not telling you that in which direction you have to go. You travel the 10 meter distance in a 5 seconds, but in which direction you go? Suppose I told you you have to go by, you have to reach the point B, which is at the 10 meter from you, and for that you have to move by the 2 meter per second velocity. Then even if you travel with the 10 meter, then you will reach up to this another point. Okay, you can reach up to this another point which is at a 10 meter. This point is also at 10 meter, this point is also at 10 meter. You can reach up to any point, okay, but you are not able to reach at the point B. So why? Because I have not tell you that the point B is in which direction. Okay, you are not aware of the direction, in which direction you have to go. You are not aware of this, in which direction you have to go. I am telling you just that you have to travel the 10 meter distance and reach the point B, which is at a distance of 10 meter, and you have to travel by 2 meter per second velocity, and you have to cover a distance with a 5 seconds. So in that case, if you are not aware of the direction of the point B, in which direction the point B is from you, then in that case you can't reach the point B. You can travel the 10 meter distance, but you are not aware of the direction, then you will not reach up to point B. So whenever we have to perform certain operation, then in that case, if we have to be aware of that particular magnitude also as well as the direction, then such a quantity is known as the, we have studied in which quantity we must have to know about the direction and the magnitude. It is the vector quantity. Okay, in case of a vector quantity, we must have to know about its magnitude also as well as the direction. So the quantities for the description of which we require both the magnitude as well as the direction are coming under the group of a vector quantity. Okay, those are the quantities for which we require both its magnitude as well as direction for their performance. Okay, we have seen for the velocity we require the magnitude as well as the direction. For the acceleration we require magnitude and the direction. In this you have to perform the displacement of a 10 meter, then also you have to know about the direction, because you have to know in which direction that point B is. So in this case, your direction is also important. Even though you know the magnitude, the 10 meter, your direction is also important there. That is, you have to travel from your left towards the point B. Then and then only you can reach up to that point B. Okay. So such a quantities which are coming under the vector quantity, they must have to know about its magnitude as well as its direction. Okay. Then and then only we can perform that particular quantity. Then and then only we can understand that particular quantities. Okay. So such quantities are coming under the group of a vector quantity. We have seen the vector quantity in which we require both the magnitude as well as its direction. Also we have seen that for the vector quantity, they can be positive or the negative, or whatever the magnitude of the vector quantity, that magnitude is equal to the its. Okay, so in that case we have to go for the some study of the vector and the scalar. Okay, so in case of a scalar, what is happening there? Which are the scalar quantities? The scalar quantities are there for the description of which we required only their magnitude. Okay, if I told you have to buy sugar from the shop, then I will tell you that just the 5 kg of sugar you have to buy. Then you can get the idea, you can understand completely how much sugar you have to buy. It's not any question there. The doubt will be clear only about its magnitude. Okay, you don't have to go for that direction, in which direction you have to buy a sugar. You can buy sugar from the any shop. That is your problem. You can buy it from the any shop. Okay, so I am telling you that just buy a sugar of 5 kg from the shop. Okay, so in that case, the mass is the physical quantity, which is a scalar quantity for the description of which we require only its magnitude. Okay, so that's why that quantity is known as the scalar quantity. Okay, so the quantities for the description of which we require only its magnitude, the quantities are coming under the group of the scalar quantity. Okay, and what is the difference between this vector and scalar is in case of a scalar we require only magnitude, and in case of a vector we require both the magnitude as well as the direction for the understanding, for the description of that particular physical quantity. Okay, so these are the vector and scalar quantity we have studied brief in our previous chapter. Okay, so if we think about the vector, then how the vector is represented, how can we represent the vector? For that purpose, if there is any quantity, suppose the acceleration is there, then for the representation of our acceleration we have to give it symbol A, and upon it we have to give one arrow. Then we can understand that this quantity A, that is the acceleration, is the vector quantity. Okay, for the representation of the vector we have to write one arrow above its symbol. Then we can understand that quantity is the vector quantity. Also, how the vector is represented geometrically, for that purpose we have to go for both the direction as well as the magnitude, and magnitude is given in terms of the length of the arrow. Suppose I have to indicate that there is the velocity of 1 meter per second. Then in that case, how to indicate the velocity of 1 meter per second? Then for that purpose I have to draw an arrow of 1 meter. Okay, I have to draw one arrow of 1 meter. Okay, I have to draw this arrow for the length of 1 meter. Then this arrow, length of the arrow will give us the magnitude, and the direction of the arrow will give us the direction. Okay, so length of this arrow gives us the magnitude of that particular quantity, and the direction of the arrow itself gives us the direction of that particular physical quantity. Okay, and in case of a scalar we have seen that just we have to give the symbol there, like in case of a mass we have to give here only m, so it is the scalar quantity. Okay, this is the scalar quantity, just we have to give here mass m. Then in case of also distance we have seen just we have to go for the s. Okay, then if here only written s, then it is the distance, and in case of a vector, suppose it is given the one arrow, then this s is not the distance but this s is the displacement, because one arrow is here and the displacement is given by the arrow upon its head because it is the one vector quantity. Okay, so that's why we have to also know about how the vector and the scalars are represented. Okay, how the vector and scalars are represented. Now if we think about some rules for the addition of the subtraction, that rules we have to study in this chapter, and depending on these rules we have to undergo some laws of the vector addition, some laws of the vector subtraction. Okay, so before that, what is important is how or which are the properties required by the vector to get the added or the subtracted. Okay, which are the properties of the vector, which two physical quantities can be added or which physical quantities can be subtracted. For that purpose we have to know their properties. That the first rule for the addition or first rule for performing the operation on the vectors is they must have the same nature. Okay? They must be of the same nature. That is, when we are going to add the displacement in the vector or the displacement in the velocity, then it is not possible because they are of the different nature. Okay? The displacement and the velocity, these are the two different physical quantities. We cannot add these two physical quantities even though they are both are the vector quantities. Okay, because if the vector is given by the 3x and it represents the displacement and the velocity is shown by the 2y, okay, then we cannot add 3x plus 2y, but we are having the another displacement and it is represented by the 3x, then we can add the 3x with the 2x, then we can get that particular value. Okay, we can add the 3x and 2x. If we have the two value 2x and 3x, then we can add these two. Okay, we can add this 2, this is the 5x, but we cannot add the 3x plus 2y. Okay, we are not getting here any value. We are not getting here any value, just we have to get 3x plus 2y. That is not the complete value. But what is the complete value? This is the complete value. We cannot add these both value. That's why this is the one rule of the addition of the vector, that when we have to go here for the addition of the vector, what is important that both the vector quantities must be of the same nature. Okay, both the vector quantities must be of the same nature. Then and then only we can add these two vectors. And the second one is very very important, that the both quantities must be as vector quantities. Okay, if we have to go for the addition of the two quantities, then it is important that the both quantities must be a vector quantities. Okay, both quantities must be a vector quantities. Then and then only we can go for the addition of that. And the second and the first rule is both must have the same nature. That is, displacement must be added in the displacement, the velocity must be added in the velocity. Okay, so that's why whenever we have to go for the operation in case of the vector, we must have to check either both are having the same nature. Then and then only we can add the both physical quantities. We cannot add the two different physical quantities even though they are the vectors. Okay, so in our next lecture we have to learn about some rules or some laws for the addition of the vectors. Okay, for the addition of the vectors we have to see the triangle addition law, the parallelogram vector addition law, also the third law, that is the law of polygon. Okay, in case of law of polygon, when two or more vectors are given, then we have to go for the law of polygon. Okay, then how to perform all these operations, that part we will study in the next lecture. Okay, so this is about the motion in a two dimension, how the motion is carried out in a two dimension, or we can say it as the motion in a plane, or we can say that particular plane as the plane of a motion. Okay, so whenever we have to go for a study of any particle, we have to see how many coordinates are changing there. If the two coordinates are changing, then that motion is coming under the category of a two-dimensional motion. Okay, so the motion in a two dimension is the motion in a plane, and in this chapter we have to study about its ultimate speed of that body and how the position changes with respect to the its x and y direction. Okay, so all this brief study we have to go with the help of our vector and scalar. Okay, and the next part we have to see in this chapter is about the projectile motion, how the projectile motion takes place, or how can we go for the calculation of a projectile motion. Okay, so in the next lecture we will study about the rules or the laws for the vector addition.